Alrighty, so today we're going to do 11.5 together in class, and then you need to do 11.5 part 2 by yourself by watching the other video. So the goal for today is you need to learn how to add and subtract rational expressions. So basically, like down here, numbers 5, 6, 7, and 8, you need to know how to add and subtract rational expressions. But the first skill that you need in order to add or subtract rational expressions is you need to know how to find something called the least common denominator. So, I don't know, maybe like you learned this in middle school? I don't know. But here's how you find least common denominators when it comes to rational expressions like this. So number 1, you have 3 fractions here, and you want to find the least common denominator. The very first step is going to be to completely factor everything. So step 1, factor. So my first denominator is already factored, so that's good. That second denominator will need to be factored into x minus 3 times x plus 3. And then that last denominator is already, it's fine. So that's step 1. Now, step 2 is to find the least common denominator. LCD, least common denominator. Let me show you what I do to find the least common denominator, and I'll try to explain it the best way I can. But your answer for the least common denominator, the way I do it, I look at the first fraction, and that denominator here, x minus 3, that's always going to be part of your least common denominator. So whatever factors are on the first denominator, that's going to be part of your answer. Now you move on to the next fraction. Your next fraction for the denominator, it has an x minus 3 and it has an x plus 3. The x minus 3 is already been included in your part of your answer here, so I don't have to include it again. But now you move on to the next factor, which is x plus 3. That's not included in my LCD yet, so then you have to include that one as well. So now, so far, between my first 2 fractions, the LCD is x minus 3 times x plus 3. And now you try it one last time with the last fraction. So you look at the last fraction. That denominator is a factor of 2x. And since that's not a factor already on my LCD, that's going to be included on my LCD. So the final answer is what I just wrote here. So number 1, the LCD would be x minus 3 times x plus 3 times 2x. And that's how you find the LCD. I'll try one more time to explain to you. Step 2, find LCD. So I guess let's try it again with problem number 2. Step 1 is to completely factor. So x plus 4 is already factored. 2x minus 3 is already factored. Now I just need to factor x squared plus x minus 12 plus 4. All right. So now you do the LCD. So the way I do it is I look at the first fraction. Whatever is on that denominator of the first fraction is going to be part of my answer. So x plus 4. Now you move on to the next fraction. Whatever factors that are on that denominator, if they're not included in the LCD already, then you have to include them. So we need to include the 2, and we need to include the x minus 3. The order in which you write your LCD doesn't matter, like the order of the factors doesn't matter. So I'm just going to leave it like this so far. X plus 4 times 2 times x minus 3. Now I'll move on to the last fraction. The last fraction has x plus 4 and x minus 3, but that's already part of your answer. You already wrote those, x plus 4, x minus 3. So then that means that your final LCD is just what we have, x plus 4 times the 2 times the x minus 3. So this is just to help you find LCDs. And now, once we know that, then we'll show you how to actually use that to add and subtract the rational expressions. So I guess why don't you try it one more time, number 3? I'll pause the video and let you try number 3 by yourself. Okay, so hopefully you tried number 3, and step 1 is to completely factor, even if you just factor a constant like this. So take out the 3 times x minus 1. This would be x plus 3 times x minus 2. and this would be x minus 2, x minus 1. So then your LCD should have been the 3 x minus 1 times an x plus 3 times an x minus 2, and then that's it. So that should have been your number 3 answer. Hopefully that's what you got. And then the last one, that's the hardest one to explain, but for number 4, I guess you kind of do the same thing. So for the LCD, you start with the first fraction. The first one is the x. So that's going to be part of your LCD. Your next fraction is an x squared. So I guess, I mean, you could write it like x times x, since that's x squared. And when you look at your LCD, you already do have one of the x's, but you're missing the other one. So then you do need to include another x for your LCD. And then that will work the same way when you get to the third fraction. That third fraction has x cubed, so that's x times x times x. We now have already the x times x on my LCD, but you need to have 3 x's like here. So we need to include another one. So that means that my LCD for number 4 will be the x cubed. And now you got to practice finding LCDs, because that's what's needed in order to add or subtract fractions. If anybody has any questions at any point, let me know so I can pause the video. Or if I do something wrong, let me know so I can fix it. So now that we practice a little bit on LCDs, let's actually do some adding and subtracting. Number 5, add and subtract the expression. State any restrictions. Okay. So the first step is going to be to find your LCD. So for number 5, oh, wait a minute. Actually, pause. I think, oh, here. So on the second page of today's notes, if you scroll down to the second page, it gives you some methods on how to add and subtract these fractions. So you have them here, and you can use this on your Delta Math quiz because it's open notes. But here it's an example of how to add if you have like denominators. So if your fractions had the same denominator, you would just put them together, like x squared over 2x minus 6 minus 9 over 2x minus 6. That would just become x squared minus 9 over the same denominator, 2x minus 6. And then you can simplify kind of what we did on Monday and list your restrictions. Now, the ones that we're going to do together are the ones where your denominator is not, they're unlike denominators. And I guess here are the steps. The very first step is going to be to factor everything and find the least common denominator. So that's what we're about to do. We're about to factor everything, and you're about to find the least common denominator. So that would be step 1. I guess let's just do that. So step 1, factor everything and find the least common denominator. This is an x squared. This would be x minus 3, x plus 3. So my least common denominator would be the x squared for sure, and the x minus 3, x plus 3. So number 5, I have found my least common denominator, x squared times x minus 3 times x plus 3. Second step, I'll just read you kind of what it says. Step 2 is it tells you here, you basically, for step 2, you want to multiply your fractions by whatever factors they're missing from the LCD. So for example, on this example that is given here, notice how the LCD was x plus 2 times x plus 4 times x plus 1. And your very first fraction was missing the x plus 1. So that means that this very first fraction needs to be multiplied by x plus 1 over x plus 1. That's what we're going to do to that one. Your second fraction was x plus 2 times x plus 1. That one was missing the x plus 4 from the LCD. So you need to multiply the top and the bottom by x plus 4. And that way, if you do that, you're going to end up having like denominators, which will be your LCD. So here's how I do it. Okay, so what I like to do is, oops, number 5. I like to put a fraction here. I kind of just combine them all at once. So what I do is on the denominator, I'm going to put my LCD because that's going to be your common denominator, your LCD. Okay, now on the numerator, I start with the first fraction. The first fraction has a 2 on the numerator, so I need to write that. And now what you do is you look at its denominator, which is only an x squared, and you see what it's missing from the LCD. So this first fraction is missing the x minus 3 and the x plus 3. So I'm going to multiply the top by an x minus 3, x plus 3, like that. And the bottom has already been multiplied because I already wrote it as the LCD. Now I continue with the next fraction. So plus, my next fraction has a 16 on the numerator. So I'll write 16. And now I'll look at the denominator. That denominator is missing the x squared from the LCD. So that means I need to multiply the top and the bottom by x squared. So I'm going to multiply the top by x squared. And then the bottom has already been multiplied. So basically, I do what the notes say, but I just skip a couple of steps here. So I do what the note said right here. I just skipped this step, and I went straight to kind of like the second and third step combined. Okay, if I'm not making any sense, then follow this, or come watch the video again. All right, so then the next step I'll do is simplify this numerator. So on my numerator, I'm going to go ahead and multiply 2 times x minus 3 times x plus 3. It's going to be 2x squared minus 18. Because x minus 3 times x plus 3 is just x squared minus 9. So when you multiply by 2 is 2x squared minus 18. Plus 16x squared. All divided by the LCD. Now you just keep simplifying your numerator. So my numerator will become 18x squared minus 18 over the LCD. At this point, you want to make sure you factor the numerator just to see if you can cancel anything. Because sometimes, like for example, on the one on the back, once you simplify your numerator, I need you to factor it so that we can see if anything cancels from the top and the bottom. Sort of like on Monday's lesson. So we need to do that right now. So right here, this 18x squared minus 18, that's going to be 18 x minus 1 x plus 1. Okay, so 18x squared minus 18, I did factor it into 18 times x minus 1 times x plus 1. And now I can see that nothing did factor or nothing canceled out. So you can leave your final answer in factor form, since we have it here in factor form already. Or, so this is for your Delta Math quiz. You can leave your answers like that. Just type that for the numerator, type this for the denominator. Or you can expand them out if you want to and write them like 18x squared minus 18 over, I don't know, this probably be like x to the 4th minus 9x squared. But you don't have to. I would just leave it as factor form like that. And that's how you do an adding or subtracting. You're also supposed to list restrictions, but for your Delta Math quiz, you don't have to list any of the restrictions. That will save just for the test. But let me just list the restrictions for this one here. The restrictions are the same as I told you earlier on Monday. Your denominators cannot equal to 0 ever. So for example, x squared can't equal to 0. So that means x cannot equal to 0. X minus 3 cannot equal to 0. So that means that x can't equal to 3. And same thing with the x plus 3. It cannot equal to 0. So And then go check your work and make sure there was nothing else that you canceled off, which we didn't. So those will be the restrictions. And that's how you do example 5. We can try it again. On example 6. I'll show you one more time how I do it, because I do skip a step. So let me show you example 6 again. Step 1, factor completely. So plus 7 minus 2. So number 6, the LCD is going to be x plus 7, x minus 2. So since that's my LCD, that's what I put on the denominator. X minus 2. So then the way I do them, so the Mrs. Garcia method is, I look at the first fraction and I see the denominator. That denominator is not missing any factors from the LCD. So that means that the first fraction doesn't have to be changed at all. It's going to stay as is. So that numerator is going to stay as x squared minus 5. Just leave it as is. Minus, now I look at the second fraction. That second fraction only has the x plus 7, so it's missing the factor of x minus 2. So that means that I need to multiply this fraction by the x minus 2. So I'm going to take the top, which is x plus 3, and I'm going to multiply by the x minus 2. The bottom doesn't need to be multiplied by x minus 2 because it already has. Like once you wrote it as the LCD, you've already multiplied the bottom by the x minus 2. Well, not that you have that done, you just now need to simplify the numerator. So let's try simplifying x squared minus 5 minus x plus 3 times x plus 2. Let me do this one first. X squared plus x minus 6. And that's being subtracted. So now I can simplify the numerator as x squared minus 5, and then minus this that I just did. Minus x squared minus x plus 6. Don't forget to change the signs on all of these because you're doing a subtraction. Minus x squared minus x minus negative 6. The denominator is just your LCD. And you can keep simplifying your numerator until you're completely done and factored. That looks just like a negative x plus 1 over this. And it doesn't look like anything is going to cancel out. Even if you try to rewrite your numerator with a positive x, like nothing will cancel out. So that means that your final answer will be what I just wrote. That would be your final answer. Your restrictions, you just look at all the denominators you ever wrote. And it looks like x can't be negative 7. And x can't be 2. I'll stop for questions. If you feel like you got it, you can try example 7 by yourself. Okay, so let's just keep practicing some more. This time with number 7. Step 1. Completely factor everything and find the LCD. So for number 7, it looks like your LCD will have to be x plus 1 times x minus 1. So the way I do it is I combine all those 3 fractions into one single fraction. The denominator is going to be the LCD. On the numerator, I need to start multiplying those numerators by whatever factors the fraction is missing from the LCD. So my first fraction has a numerator of 2x. and is missing the x minus 1 factor. So I need to multiply that by x minus 1. Minus 3x. The second fraction is missing the x plus 1. So I need to multiply that numerator by x plus 1. Plus 6. The last fraction is not missing any factors from the LCD, so that's not going to be multiplied by anything. It's just going to be a 6. Not that I have that, you just need to simplify the numerator. So this will be 2x squared minus 2x. Carefully distribute the minus 3x. Minus 3x squared minus 3x plus 6. This is, the denominator is still the same. And now keep simplifying your numerator. Negative x squared minus 5x plus 6. Is that right? Yeah, that looks right. The denominator is still just the LCD. And this negative x squared minus 5x plus 6, you need to factor it just to make sure that nothing cancels. But we're going to have to factor this. I don't like to factor with a negative x squared, so let me take out a negative here first. Negative x squared plus 5x minus 6. Okay. Okay, so since I took out a negative out of the numerator, I'm just going to put negative here. And now I have to factor x squared plus 5x minus 6. X plus 6, x minus 1. That looks right. And this is why it's important to always factor your numerator just to see if anything cancels. In this case, you notice how on the numerator you end up with an x minus 1, and on the denominator you also end up with an x minus 1. You do need to cancel those out to simplify your answer. So your final answer that you would type in, I guess for your quiz, you can just leave the negative out there. Negative parentheses x plus 6 over x plus 1. You can write it like that in factor form, or you can distribute the negative if you want to. Negative x minus 6, both will be correct. So that would be the answer you would type for your quiz, numerator and denominator. Now let's do the restrictions, because you'll need to know the restriction for the test. Not on the quiz, but let's just practice it anyway. So for your restrictions, your denominators cannot equal to 0. So x can't equal to negative 1. And then the other factor that we canceled out, x minus 1 can't equal to 0, so that means that x can't equal to positive 1 either. And that is how you do example number 7. Pause. So the last example is going to be slightly different because those denominators are going to be like number 4 up here that we did. So let's try to do example 8 now. So example 8, the first thing we're going to do is we're going to get rid of those negative exponents by rewriting the question. So number 8, you have a 2, which is just a regular 2. There is no negative exponent with the 2, so the 2 is going to stay right there. Now the x has a negative 1 as the exponent, so I'm going to put it over x to the first to make it positive. Plus x minus 1 is going to stay right where it is on the numerator because it's not being raised to a negative exponent, so let's leave it as x minus 1. However, the x to the negative 2, that's going to come in the numerator to make it positive. X squared minus x squared plus 5 over x cubed. And then plus a 5 over x cubed. So the first thing I did on number 8 was I rewrote the question so that we would have positive exponents, and that creates a rational expression, like a fraction. Now you do the same thing I've been trying to show you in all of these. We do the LCD. So let's put the LCD right here. So the LCD for this is going to include the x, but then you have an x squared, and then you can have to have an x cubed. So at the end of the day, the LCD is going to be the x cubed. Now that you have the LCD, you do what I was trying to show you in all the other ones. I'm going to combine all these 4 fractions into one single fraction that has a denominator of x cubed, which is the LCD. And now what I do is I start looking at the numerators. So my very first fraction has an x, but it needs to be an x cubed. So that means that this first fraction is missing an x squared. So I'm going to multiply the numerator by x squared. And then I'm going to keep going. Plus my next fraction has an x squared, but it needs to be an x cubed, so it's missing an x. So I'm going to multiply my numerator by x. Make sure you multiply the whole numerator by x, like x minus 1 times x. Minus my next fraction isn't missing anything. It's already the x cubed, which is what we needed. So that one's not going to be multiplied by anything, but make sure you keep it in parentheses so that you correctly subtract x squared and subtract a 5. And then last fraction isn't missing anything, so it's just going to be a plus 5. Now you just simplify the numerator. So let's simplify this mess. 2x squared plus x squared minus x squared minus 5 plus 5. Okay, so let's keep simplifying. I don't know if I did this right, but let's keep going. So it looks like this is going to be a 2x squared minus an x just over x cubed. Like, does anybody agree or disagree with this 2x squared minus x? Anyone? Okay, I guess we're going with it. Because the one on the answer key is different. Okay. So now make sure you completely factor your numerator to see if anything cancels. So on my numerator, I have an extra x that can be factored. So x times 2x minus 1 over x cubed. So because I did factor an x out of the numerator, then I can cancel it with one of the x's on the denominator. So for my final answer, I would write that's going to cancel with one of these. So that'll become a square. So 2x minus 1 over x squared. Did anybody get this answer? 2x minus 1 over x squared?
Yes.
Okay, thank you. So then it looks like on my answer key, somehow I messed it up, so I'll have to fix it. On my answer key, I ended up with a 2x plus 1. So I'll have to figure out what. Oh, I think I just wrote this number wrong on my key. That should have been a minus. I'll fix it on the... Okay, so my answer should be 2x minus 1 over x squared. And then again for the restrictions, your denominators can be 0, so it looks like just x can't be equal to 0. And now that is 11.5, the first half, which you'll need for your quiz. Practice this using your Math Excel homework first. And then you're going to have to go watch the second video, the 11.5 part 2. So good luck studying.